Welcome to Brain Vision.
So to start this problem, we're going to do a free body diagram. So we have A, B. At A, we have a force in the y direction. Then we have C. And then we have D. So that's our free body diagram. And we're going to take the moment at point D so that we can solve for AY. So moment's always equal to 0. So we have 50 times 2 minus 20 times 2 times 1 minus AY times 4, 0. So for this, we're just doing the middle force here, so 20 times that entire distance of this load, so 40, and then you times it by its half the distance. So solving for this, we get AY is equal to 50 kilonewtons. And now I'm going to solve for dy, and doing that I'm going to do the sum of forces in the y direction. And so we have dy plus AY minus 50 minus 20 times 2. And we already know what AY is, so we can just plug that in. And solving for dy, we get 75 kilonewtons. So now we can look at our shear forces over this beam. And starting at A, our shear force is going to be equal to AY. So VA is equal to 15 kilonewtons. And then we're going to look at C. And C is just AY minus 50, since we have a downward force at 50. So it's just 15 minus 50 is equal to negative 35 kilonewtons. Now we're going to look at VD. And at VD, we have AY minus 50 plus dy. So it's just 15 minus 50 plus dy, which we had solved, so 75. And that's going to equal 40 kilonewtons. And then last but not least, we look at the shear force at B. So AY minus 50 plus dy minus 20 times 2. And solving for all that, we get 0. So now we're going to look at the bending moment equation for our beam. And bending moment is simply just our shear force value times the distance of the particular beam we're looking at. So we're looking at AC, and if we calculate the bending moment at A, it's just AY times 0, because our starting distance is 0. So MA is equal to 0. And then we're going to look at the bending moment at C. So at C, we do, or sorry, I'm going to say MC is equal to 15 times 2 minus or just 15 times 2 actually. And that's equal to 30 kilonewtons meters. And that's because our shear force from A to C is 15. And now I'm going to look at the bending moment at C. And at C we have 15 kilonewtons, right? So we're just doing 15 times 2 minus 50 times 2 minus 2. And we get 30 kilonewtons meters. And now we're going to look at the bending moment at D. So we have 15 times 4 minus 50 times 4 minus 2. We get negative 40 kilonewtons meters. Now I'm going to calculate our bending moment between D and B. So for D, we have 15 times 4 minus 50 times 4 minus 2 plus 75 times 4 minus 4 minus 20 times 4 minus 4 over 4 minus 4 over 2. And that's equal to 30 kilonewtons meters. And last but not least, we look at B. And for B, we have 15 times 6, our entire distance, minus 50 times 6 minus 2, plus 75, 6 minus 4, minus 20, 6 minus 4 times 6 minus 4 over 2. And that all equals to 0. So now we can do our shear and moment diagram. So I'm just going to copy this over here. So that's our shear. That's going to be our moment. A, C, D, B. So we're just plotting the values that we had found, right? So we started with 0, and then we went up to 15, constant up to C, and then we went down to negative 35, and that's constant till we go back up, and we go to 40, and we return back to 0. So this is 15, this is negative 35, and this is 40. And for our moment diagram, we start from 0 and then we go up to 30. And then we go down, negative slope, to negative 40. And then we have a parabola that returns to 0. So negative 40 and 30. And our maximum shear force is at D, which was 40 kilonewtons. And our maximum bending moment is also 40. And that's our absolute value.